In this video, I'm going to do a question that we solved before with 2D kinematics, but this time do it using energy. Now before, we had a person standing on the top of a building, throwing a brick, trying to get it to hit with the highest possible speed, trying to figure out which direction to throw the brick. What we ended up finding out took a lot of work, but no matter what angle the person throws the brick at, it's going to hit with the same speed. Now, we're going to look at this same situation using work and energy. There are no external forces, so final energy will be equal to initial energy. So let's see, that would be K final plus gravitational final plus the elastic or spring potential energy final plus the thermal energy final equals K initial plus G initial plus U E initial plus E thermal initial. Alright, thermal energy. If we ignore wind resistance, there's going to be no thermal energy that's generated. So whatever thermal energy there was at the beginning, same as what it was at the end. So those go away. There's no spring. So elastic potential energy goes away. Kinetic. There is kinetic at the beginning, there is kinetic at the end. So both of the kinetic energies have to stay. Gravitational. We can choose where we want to set gravitational potential energy equal to 0, right? I want to set it down here equal to 0 because this is the lowest point the brick will reach. So if I say this is my y equals 0 and then 18 meters up is my initial, so that's y final. Y initial is 18 meters and then delta y is negative 18 meters. So I can do that. That makes the gravitational final equal to 0. So at the final position, there is only kinetic energy. And kinetic energy is 1/2 mv final squared. All of these are gone, equals initial kinetic energy. 1/2 mv initial squared. Now it's squared plus gravitational. That's m times g times the y initial. And that's it. M is in all three, so we can cancel it. So the m's can all go away. V final squared is 2 times all of this. 2 times, so it's V naught squared plus 2g y initial. So V final is square root of that. V naught squared plus 2g y initial. You notice that the angle never even appeared? When we did this with kinematics, we had a lot of sines and cosines in here. If you look at it from energy, you don't need any of that. If we draw an energy bar graph for this, so initial and final, however much it had at the beginning, it has the same amount at the end. At the end, we'll use blue for kinetic. So, blue for those. At the end, there's only kinetic energy. Whole thing is blue. At the beginning, there is kinetic and gravitational. So if I use red for gravitational, then some amount at the beginning is gravitational, some amount is kinetic. This can be another direction to approach the problem. I jumped in straight with equations. If it helps you to start here instead, you can do that. You can say initially it's got some gravitational, some kinetic. Put them in there. At the end it's got the same amount that it had before, but at the end it's all kinetic.